If your indicator suddenly went dead, the worst thing you can do is start buying parts at random. Because the same symptom can mean 3 completely different problems, and the cheapest fix is often a 5-minute check that people skip. This is especially true when you're searching turn signals not working on Suzuki Swift and you're hoping it's just a bulb. Sometimes it is. But when both sides quit, or they work only when they feel like it, bulbs are rarely the real story. So before touching a screwdriver, you need to classify what the car is actually doing. Not what you think it's doing. What it's doing. Here's the first split that matters: do the hazard lights work? Hazards and turn signals share a lot of the same hardware and wiring pads. If hazards work perfectly but the turn signals don't, that points you away from bulbs and away from the lamp grounds, and toward the control side, the stalk switch, the hazard switch's internal contacts, or the control module logic depending on year. If hazards also don't work, now you're thinking power supply, a main fuse, a shared ground, or a flasher/control unit problem. Second split, is it one side or both sides? If only the left side is dead but the right side is fine, that's usually a local issue, a bulb, a socket, a connector, or wiring to that side. If both sides are dead, that's usually a shared issue, fuse, hazard switch path, stalk switch feed, or the flasher/control. Third split, is it fast blinking, normal blinking, or no blinking at all? Fast blinking is the classic, one bulb is out, signal on many cars, but it can also be high resistance from corrosion in a socket, a partially melted bulb holder, or an LED bulb that draws less current than expected. No blinking at all can mean no power, a fail control, or a short that's blowing a fuse. Fourth split, what does the dashboard indicator do? If the cluster arrow lights up solid without blinking, that's different from not lighting at all. If it blinks fast on the dash but the outside lamps don't, that's different again. The dash is basically telling you what the car thinks is happening in the circuit. Once you've sorted those 4 things, you've already cut your diagnostic time in half. Now, the 5-minute check that saves people from replacing the wrong parts is this: hazards versus turn signals, back to back, while watching both the cluster and the exterior lamps. Because it tells you whether the car can flash the lamps at all. If hazards flash all 4 corners normally, the bulbs, most of the wiring to the lamps, and the grounds are probably okay. That means your problem is upstream, the turn signal command path. If hazards don't flash either, stop blaming the stalk and start looking at power and the shared control. Let's talk about the quick checks that actually move the needle, starting with the simplest, bulbs and sockets. Even if you suspect it's not a bulb, you still want to inspect them, but you do it intelligently. If you have fast blink on one side, go straight to the front and rear indicator bulbs on that side. Pull the bulb and look for a broken filament if it's a traditional bulb. But don't stop there. Look at the socket itself. If you see greenish corrosion, moisture, or a dull, burn contact, that can create resistance. Resistance makes the system think the bulb is out, and it can also make the bulb intermittent. It works when you hit a bump, then dies at the next stoplight. A common trap is swapping bulbs left to right and calling it tested. That only proves the bulb can light. It doesn't prove the socket can carry current under vibration and heat. If the socket is loose, the bulb can pass a quick test and still fail on the road. If you find corrosion, the goal is clean metal-to-metal contact. Light cleaning and tightening the contact tabs can help, but if the plastic is heat damaged or the terminals are pitted, the real fix is replacing the holder or the lamp assembly connector. Heat damage matters because it changes spring tension. The bulb sits there, but it doesn't clamp tightly anymore, and the circuit becomes a coin toss. Now, if both sides are dead, bulbs are unlikely to be the cause, but sockets can still be part of the story if there's a shared ground issue. That's why you should also do a quick ground sanity check. Grounds are the silent killers of lighting circuits. A bad ground can make current backfeed through other bulbs, causing weird behavior, indicators glowing dimly, brake lights affecting turn signals, or the dash indicator doing something that makes no sense. You don't need a wiring diagram to do a basic ground check. If you have a multimeter, measure voltage at the bulb socket with the turn signal commanded on. If you see close to battery voltage on the power side but the bulb doesn't light, suspect the ground side. If you don't have a meter, a simple test light can still tell you a lot. Clip it to a known good ground and probe the socket's power terminal. Then clip it to battery positive and probe the ground terminal. If the ground is good, the test light should light strongly. If it's weak or dead, you've found a ground problem. Where do these grounds fail? Often near the rear lamp area where moisture and road grime live, or at a body ground point where multiple wires bolt to the chassis. If the car has had rear end work, a ground eyelet can be left loose or painted over. Paint is an insulator. A ground bolted onto fresh paint is basically a ground that works only when it feels like it. Next, fuses. People love to look at a fuse and declare it good. That's how you waste an afternoon. A fuse can have a hairline break you can't see, or the fuse blades can be oxidized, or the fuse box contact can be loose. The correct quick test is power in and power out. With the circuit commanded on, you should have power on both sides of the fuse. If you have power on one side only, the fuse is blown. If you have power on neither side, the problem is upstream, the feed to that fuse, ignition switch logic, or a larger fuse. Also, if a fuse is blown, don't just replace it and celebrate. Ask why it blew. Turn signal circuits don't usually blow fuses for fun. A blown fuse can mean a short to ground in a lamp socket full of water, a pinched wire in a loom, or a trailer wiring hack if the car ever had one. If you replace the fuse and it pops immediately when you signal, that's your sign to stop guessing and start isolating. Unplug one lamp assembly at a time and see when the fuse stops blowing. That's how you narrow down the short without tearing the whole car apart. Now, there's one component that causes a ridiculous amount of confusion, the hazard switch. On many cars, the hazard switch isn't just a button that tells the car flash all. It can be a junction point for the left and right indicator circuits. Inside that switch are contacts that route power and signals. If those contacts wear, get dirty, or crack, you can lose turn signals, hazards, or both in ways that mimic a bad stock switch or a bad flasher. Here's the tell: if your hazards are intermittent, or they work only if you press the hazard button a few times, or the turn signals come back to life after you toggle hazards, the hazard switch is immediately suspicious. That doesn't mean it's definitely the switch, but it means you should not ignore it. People replace the stalk, then the relay, then the bulbs, and only then discover the hazard switch was the real culprit. So what about the flasher relay? Older systems use a dedicated flasher relay that clicks and creates the blink. Newer systems often have the blinking controlled by a body control module, and that click you hear can be a speaker sound, not a physical relay. The diagnostic approach changes depending on which system you have, but you can still reason it out without getting lost. If you can hear a distinct mechanical click from a relay area when you signal, that suggests a physical flasher or relay is involved. If there's no click at all, it could be a dead relay, no power to the relay, or a module not commanding it. If the hazards click but the turn signals don't, that again points away from the relay itself and toward the command path, stock switch or hazard switch routing. And this is where the phrase, turn signals not working on Suzuki Swift, becomes tricky, because different Swift model years and markets can be wired differently. Some will have a more traditional flasher setup, others will integrate it into a control unit. The point isn't to memorize which year has what. The point is to use the behavior to tell you where to look next. Let's move from quick checks to component level diagnosis, but still keep it practical. Start with the stock switch logic. The stock is basically a set of contacts that sends a left or right request. If hazards work but turn signals don't, the stock is a prime suspect, but it's not the only one. The wiring between the stock and the control can fail, and the connector at the steering column can loosen. Also, if the steering wheel has been removed for any reason, or if there's been work around the column, connectors can be left not fully seated. A classic symptom of a failing stock is intermittent operation that changes with steering wheel position, or a turn signal that works if you hold the stock in a certain spot but not when it clicks into detent. Another is a signal that cancels randomly or won't latch. Those are mechanical and contact wear clues. Testing the stock properly usually means checking whether the left/right request signal changes when you move it. Without a wiring diagram, you can still do a basic sanity check by focusing on what's shared and what's not. If left and right both fail the same way, it's less likely that both sides of the stock fail simultaneously, though it can happen. If only left fails and hazards still flash left lamps, the left side wiring and lamps are likely fine, so the left request path is the issue, stock contact, connector, or control input. Now, the hazard switch again. Because it can sit between the stock and the lamps. If toggling hazards affects turn signal behavior, you're not imagining it. That's a real clue. Sometimes the internal contacts oxidize and the circuit wakes up after a few presses. If you see that pattern, replacing the hazard switch can be a clean fix compared to chasing ghosts. Next, wiring and connectors. Intermittent turn signals are often not a smart problem. They're a dumb problem, a wire that's broken inside insulation, a connector that's loose, or a pin that's backed out. Rear lamp wiring is exposed to moisture. Front lamp wiring is exposed to heat and vibration. And any wiring that passes through a moving hinge area can fatigue over time. If your issue is only at the rear, pay attention to the rear lamp connector and the harness routing. If it's a hatchback and there's wiring that flexes with the hatch, that loom can develop broken conductors. The symptom can be maddening: signals work with the hatch open, fail when closed, or vice versa. You don't need to fully disassemble the car to check this. You can gently move the loom while the signal is on and see if it cuts in and out. If it does, you've found a mechanical fault. If your issue is only at the front, check for water intrusion in the lamp area, and check the bulb holder for heat damage. Front indicators can run hot, and a slightly loose bulb can arc, which pits the contacts and accelerates failure. Now let's address fast blinking, because it's where people get misled. Fast blink is not the car saying, your relay is bad. It's the car saying, the circuit current looks wrong. That can be a bulb out, yes. But it can also be a bulb that's technically lit but drawing less current because of resistance at the socket. It can be an LED bulb installed by a previous owner. It can be a poor ground. So if you see fast blink, don't jump to the relay. Go to the corner that's not contributing properly and inspect the bulb and socket first. If you have LEDs in the indicators and you didn't install them, assume nothing. LEDs can cause hyperflash unless the system is designed for them or has load resistors or coding to compensate. The fix might be as simple as returning to the correct bulb type. But be careful with resistors, they get hot, and sloppy installation can create new problems. If you're not comfortable with that, the safest path is using the correct bulbs and ensuring the sockets are healthy. Now, what if nothing works at all? No turn signals, no hazards. That's when you stop thinking about corners and start thinking about shared power and shared control. Check the relevant fuses with the power in/power out method. If the fuse is good and powered, then you're looking at the control element, flasher relay or module, and the hazard switch as a gateway. If the hazards don't work but the brake lights and other lights do, that doesn't automatically clear the power supply. Different circuits, different fuses. You need to test the specific fuse feeding the indicator/hazard system. If the fuse keeps blowing, don't keep feeding it fuses. That's how you melt wiring. A repeated blow is a short to ground until proven otherwise. Water in a socket is a common cause. A crushed wire behind a lamp assembly after a minor bump is another. Unplugging lamp assemblies one at a time is a simple isolation technique. When the fuse stops blowing with a certain lamp unplugged, you've narrowed it down to that branch. And then there's the scenario that scares people, the body control module. The truth is, modules do fail, but they're not the first suspect. They're the last suspect after you've proven power, ground, fuses, bulbs, sockets, and switches. The reason is simple: modules are expensive, and misdiagnosis is common. Also, a module can appear bad when it's actually protecting itself because it detects a short or overload. Fix the short and the module comes back. So how do you know when to stop and get professional diagnostics? Here are the practical stop signs. If you have repeated fuse blowing and you can't isolate it quickly. If you find melted connectors or signs of overheating in the fuse box. If multiple unrelated electrical systems are acting up at the same time. If you suspect a module but you can't confirm inputs and outputs. At that point, a shop with a scan tool and wiring diagrams can save you money compared to replacing parts blindly. Now let's turn all of this into a clean decision path, the kind you can actually follow in your driveway. If one side is out and the other side works, start at that side's bulbs and sockets. If you find a dead bulb, replace it with the correct type and recheck. If the bulb is fine, clean and inspect the socket and connector. If the socket is heat damaged or loose, replace the holder or repair the connector. Then check the ground near that lamp area if the problem is intermittent or dim. If both sides are out but hazards work, focus on the stalk switch and the hazard switch interaction. Toggle hazards and see if turn signals change. If they do, suspect the hazard switch contacts. If they don't, suspect the stalk or its connector. If you can hear clicking with hazards but not with turn signals, that's another hint that the flasher/control can operate, but the turn request isn't getting through. If both sides are out and hazards don't work, go straight to fuses and power feed. Test, don't eyeball. If the fuse is blown, replace it once and see what happens. If it blows again, isolate the short by unplugging lamp assemblies. If the fuse is good and powered, then you're looking at the flasher/control and the hazard switch as the shared gateway. If you have fast blink, treat it as a current problem, not a relay problem. Check for a bulb out, corrosion, a poor ground, or LEDs. Fix the load issue first. And after any fix, confirm it properly. Don't just see one blink and call it done. Check left and right, hazards, front and rear, and watch for a minute. Wiggle the harness near the lamp and near any hinge area if the issue was intermittent. Because intermittent problems love to pass a quick test and then return the next morning. One more nuance that matters, moisture. If you clean corrosion and it works, but the lamp housing has water inside, the problem will come back. The long-term fix is addressing the water ingress, a cracked lens, a bad seal, or a missing cap. Otherwise you're just resetting the clock. So when someone types, turn signals not working on Suzuki Swift, what they usually want is the one magic part to replace. But the Reolwin is not replacing anything until the symptom pattern tells you where the fault lives. Hazards versus turn signals. One side versus both. Fast blink versus dead. Dash behavior versus exterior behavior. Those 4 observations are your map. Most of the time, the fix ends up being boring, a corroded socket, a tired bulb holder, a loose ground, a fuse with poor contact, or a hazard switch with worn contacts. And that's good news, because boring fixes are cheap. If you take one thing away, make it this: don't start with parts. Start with the pattern. When you do that, turn signals not working on Suzuki Swift stops being a mystery and turns into a short, logical hunt where every check tells you what to do next.